Okay, so today we're going to talk about Aristotle and Galileo, and this is Hewitt 2:1 to 2:2. So let's talk about Aristotle first, his ideas of motion. Aristotle had classified motion as natural motion, and what that means is that every object has a proper place determined by a combination of four elements: earth, water, air, and fire. Now, any object not in its proper place will then try to get there or strive to get there. For example, stones will fall back to the earth. Smoke will rise because it's air. Okay, so this is what Aristotle said: things move to go back to where they belong: earth, water, air, and fire. Straight up or straight down for all things on earth. So this natural motion is things will either go up or down on earth. Now, once you get beyond earth and out into the solar system, all the motion is circular. And this is how he explained how the sun and the moon continually circle the earth. Again, this was an earth-centric idea that earth was the center and everything else was around it. We know now that's not true, but Aristotle then had reasoning for that. So everything on earth was straight up or down, but beyond earth, motion is circular. Now, how about things going side to side? Well, he came up with something called violent motion, and this is produced by external pushes or pulls on objects. So if an object was not going up or down, but going left to right or side to side, it was because of pushes or pulls, this violent motion, and wind blowing a ship, right, to the left or to the right or side to side in relation to where you're at. That's how he described that motion. Now, Galileo came along and said, Aristotle, you're full of it. Now, this was in the 1500s, so Aristotle was way before him. But here's what Galileo discovered. One thing he discovered is that objects of different weight, okay, so heavy and light, they fall to the ground at the same time if there's no air. So if we didn't have air to push back, objects would fall at the same time. And a moving object will stay moving as long as there's no force to keep it from moving. And so if there's no friction, an object would move forever, right? We could have something that would move forever as long as there wasn't friction acting on it. So that was what Galileo determined movement was. So here's his terminology. A force is a push or pull, thanks to Galileo. Inertia, and this is an important term, and this is a term that you're going to have to wrap your head around. One, it's a property of matter, and it means that you resist change. So if you have a lot of inertia, you resist change. And inertia, when we talk about objects, is resisting change in motion. Inertia depends on the amount of matter, so it depends on mass. More mass equals more inertia. I'll say that again. More mass equals more inertia. So think of it this way. If you have a pebble on the ground and you have a giant boulder, which one is easier to move? Well, the pebble, because it's smaller, because it has less mass, which means it has less inertia. So it will have less resistance to change. While the boulder, on the other hand, has more mass, which means its resistance to change is greater. Okay, so inertia and mass go together, and inertia is the property to resist change. So let's look at Galileo and how he tried to explain this with a ball rolling, right? So if we have a ball that's rolling downward, it picks up speed. If it's rolling upward, it loses speed. But if it's on a horizontal plane, it should move at that speed indefinitely as long as there's no other force. Now, if the ball does come to rest, it is not due to nature, but due to another force, which we know now is friction. So repeat that. Going down, gravity is the force that's making its speed increase. If it's going up, gravity is what's causing the speed to decrease. But if we're on horizontal, there's no gravity. But the object will go with constant velocity until another force acts on it, which in this case is friction.